Hello children, so welcome to AIMS India's online class session. Today from physics subject, force topic we are going to continue. So in our previous video, we have learnt about contact forces and we have learnt about first force, muscular force which can be created by using our muscles. And second one, we have also learnt about frictional force, means acts between two surfaces which are in contact. Regarding the two forces we have learnt already. Now let's see third kind of contact force, which is normal force. Sometimes it is also called as support force. So here, so place your science book on the table as shown in this figure. So let's place one science book on the table. Now, is it in the state of rest? Now, actually, according to our observation, if the observer is the person standing beside, according to him, the book is under rest position. Now the question is there any force acting on that book? Is there any force acting on that book? Or imagine that the table has disappeared suddenly by magic. So by magic, you imagine that this table has disappeared suddenly. So what will happen then? Because as there is no support to the book, as the table is disappeared, the book which is on the table will fall down due to gravitational pull of the earth. Because the earth will be having a force called gravitational force. So because of which our gravitational force try to attract all the objects which are on the earth. So because of that, the book will fall down to the earth. Okay. Next, suppose if table is there. Now the question is, so in the absence of table, the book is falling down. Gravitational force is acting. Now the question is, if there is table, then also the gravity works or not? Yes, it will work. If there is table, then also gravity will try to pulls the book down, but it does not fall because it is supported by the table. So in the presence of table or in the absence of table, in both the cases gravity will work. But when table is there, the book is not falling down. Why? Because the book is supported by the table. So therefore, there exists a force. So there exists a force which supports the book against the gravity by pushing it upward. So why the book is not falling down means, so there is a force. There is a force actually, so which is trying to push it upward. So because of that, the book is not falling down. So what do we call this force? So here, if this is the plane or this is the support for the book and the table, this is the plane of contact. So here a direction perpendicular, which is perpendicular to the plane of surface is said to be normal. This will be perpendicular. Perpendicular means 90 degrees angle between what? Between this line and between the plane of contact, if the angle is 90 degrees, so then this line is called perpendicular line. This line is called perpendicular line, or this line is called normal. This line is called normal. So this plane is a solid surface. This plane is a solid surface. It exerts on any object a force in the normal direction or perpendicular direction. That force is called normal force. Okay, children. Now the question is, when the table is there, why the book is not falling down means, when the table is there in the downward direction, gravitational force will work. Because of that, book will gain some weight. To balance that weight, the solid surface in the normal direction show another force which is called as normal force, which is equal to weight, of the book, but in opposite direction. If the weight is acting downwards, normal force will act downwards. So that's why the book is not falling down. So this is called normal force, or this is called support force. Or when you try to press a spring down, so you are pushing downward. So you are exerting one kind of downward force. What you will experience? You will experience a force which is pushing your hand up. That will be called as normal force. So normal force will be exerted by the solid surface of contact. So next. So in the above example, means in this example, the downward gravitational force is being balanced by the upward normal force. Here, downward gravitational force Fz is balanced by the upward normal force Fn. These two forces are equal in magnitude. Fz equal to Fn. Means if it is 10 newtons, this is also 10 newtons. They are equal in magnitude, but acting in opposite direction. So because of acting in opposite direction, one value will become plus 10 Newton, another value will become minus 10 Newton. If we do their sum, if we add, total force will be 0, or total force, here it is called net force. Net force acting on the book will be 0, and the book will be in equilibrium condition. Equilibrium condition means under rest position. With respect to observer who is staying on the ground, according to him, the book will be in equilibrium position or rest position, or net force on the book will be 0. Though both the forces are equal in magnitude, but their direction will be opposite. Suppose if there is a book, from right side we are applying 18 Newton force towards right side, 20 Newton force towards left side. What will be the net force? If right side force is taken as positive, left side force will be taken as negative. Both their sum will minus 18 plus 20 equal to 2 newtons. 2 newtons. As left side force is more, net force also will be towards left side. Left side force also will be towards left side. So minus 2 newtons. So in this case, the net force is not 0. So that's why we can observe movement of book towards left side. But whereas in this case, the book is in equilibrium. Why? Means the net force is equal to 0. So this is about normal force. Normal force is shown by the surface of contact, solid surface of contact. In what direction? perpendicular to the surface of contact. It is also called as normal force and support force or perpendicular force. Next, tension force. So here, as shown in the figure, a stone is suspended with the help of a string and its free end is tied to the ceiling. So one end of this is the string, S-T-R-I-N-G. Here spring is different, children, string is different. Spring is different, string is different. Okay. Or the wire between the electric poles. Wire between the electric poles may be an example of string. String is different and spring is different. Here we have taken a spring. One end is, to the one end we have suspended a stone. The other end of the string is tied to the ceiling. Tied to the ceiling or one rod. Now the question is, what is the state of the stone here, or what forces are acting on the stone, or what will happen if the string is broken? If we try to know the answers of all these questions, then we can understand what is a tension force. Here, fourth kind of contact force is tension force. So which will exist in the strings or springs, mainly on strings. Here, so we know that the stone would fall down due to gravitational pull or weight of the earth if the string is broken. If the string is broken, this will fall down due to gravitational force of the earth, Fg. Because of that, the stone will get some weight, or we can call because of weight. Because of the stone weight, it will fall down if the string is broken. Okay. But when it is tied to a string, when the stone is tied to a string, so gravity pulls down the stone all the time, but it does not fall down because it is supported by the string. Means there exists a force which supports the stone against the gravity by pulling it upward. What do we call this force? This force is called as tension force, because there on the stone the force of gravity is acting downward. If the string is broken, it will fall down. But when the string is not broken, though the gravitational force is acting on the stone, but it will not fall down. Why? Means opposite to that, in the string will develop a kind of force in the upward direction, balancing the downward force. So this upward force developed in the string against the gravity is called tension force. So what do we call this force, children? This is called tension, because which always pulls the body along the string. If weight W is acting downwards, so then tension T will be acting upward. So tension also a contact force. Or when you try to stretch a rope, or when you rope or string, when you try to stretch a rope or a string, the tightness of the rope, you can observe the rope becoming somewhat tight, or the string is becoming somewhat tight. The tightness is developed because of the tension. So here in this example, the gravitational force Fg or weight W is balanced by upward tension force, as shown in the figure. Both of them, they are balanced. Weight equals to tension. But this value will if one value is positive, another value will be negative. Another value will be negative. But net force will be 0. Net force will be 0. So that's why we can say that this stone is in equilibrium state, because net force is 0. Next, that is about tension force. Now, second type of forces acting at a distance. So far, we have learnt about contact forces. So one is muscular force. We have learnt about muscular force, then about frictional force, so then about normal force, then about tension force. Like that, 4 types of contact forces we have learnt. So now, second category, forces acting at a distance. Forces acting at a distance. In that first kind, magnetic force. In that first kind, magnetic force. Let's see what a magnetic force is. Let's see what a magnetic force is. So take a sewing needle. Take a sewing needle like this. Take a needle. First you have to take a needle. So rub it with a bar magnet several times, always moving the magnet in the same direction. Always moving the magnet in the same direction. Means from top to bottom, top to bottom, top to bottom. Means you have to start from top, you have to come to up to bottom, then you have to go back top to bottom, go back top to bottom. Means in similar direction, if you rub the sewing needle with the bar magnet so many times, what happens? It will become as a magnet. So here, does the needle get magnetized? Yes, because in 6th class you might have learnt by single touch method. By single touch method, we can turn a magnetic material into magnet. So here, the needle always acts like a magnet. Suppose with the help of magnetic compass, we can identify north and south poles of the needle. So first, by single touch method, we have turned a sewing needle into a magnet. Now we can identify their south pole and north pole by this small experiment. So here, what you have to do? Pin a red colored foam ball to south pole and white ball to north pole of the needle. So if you take the needle near to the compass, if the compass shows north pole, means what we know, opposite poles will attract. So here north is coming, means there will be south. So opposite end will be north. Like that we can identify the north and south pole for the magnetic needle. To the south pole, we have to attach a red color foam ball, and for the north pole, white color foam ball, red color foam ball. Like this, white color foam ball, red color foam ball, we have to attach it to the magnetic needle. So we have to make another needle in the same way. Another needle which is magnetized, and red foam ball to the south pole, white foam ball to the north pole. Like this, two needles we have to make. Next, float. Okay, 2 we have to make. Let's drop it in a bowl of water. So let's drop first one in the bowl of water. As we have attached foam, means very lightweight, it cannot be dissolved into the water. So it start floating in the water. Next, another needle float that also in the water, such that facing side by side, that like ends are facing side by side. like ends are facing side by side. So what happens that you have to observe? Now next you have to place the needles in such a way that unlike ends are facing each other. So what you have observed? So what you will observe, when the unlike poles, when the like poles are facing each other, you can observe repulsion. When the unlike poles are facing each other, you can observe attraction. So you can observe that the red end of one needle and white end of another needle attract each other, and ends with the same color repel. Means, so like poles repel or push each other, unlike poles attract or pull each other. Means the poles are showing one kind of push or pull. Push or pull. So this action of push or pull results in magnetic force. So the whatever push or pull force we are observing between the needles or between the foam balls, so that push or pull we can call it as a magnetic force. Means a magnet can attract or repel another magnet without contact with the magnet. Here there is no contact. Here they are not in contact. Here also they are not in contact. Or here also the foam balls or the two needles, they are not in contact. But still they are able to attract, they are able to repel. So why? Means without contact, one kind of magnetic force will exist between them. So magnetic force is a kind of push or pull which acts at a distance, or it is an example of force acting at a distance. Next, we have electrostatic force. So if you take a balloon, if you inflate it and tie up the open end after inflating it. So inflate means making it bigger or blowing air. Blowing air into the balloon is called inflating. After blowing air, size will increase. That is called inflating. So we have to inflate the balloon first, and we have to tie up the open end with a thread. Means we have to make precautions such that the air inside the balloon will not come outside. So the balloon will bulges out. Now cut a paper into small pieces like this, and place them on the floor. We have to place them on the floor. Now rub the balloon with a paper or with shirt or with hair. We have to rub it for some time, and we have to bring the balloon near the pieces of paper. So what happens now when you rub the balloon for some time to the wall, to the hair, or to another paper, or to one woolen shirt, like that? If you brought it to the pieces of paper, what do you observe? Are the bits of paper pulled towards the balloon? So why does the balloon are pulling or attracting the pieces of paper? So you can observe that the pieces of paper will get attracted to the balloon. So why? Means when the balloon is rubbed with paper, it acquires an electrostatic charge on its surface. So the balloon is now said to be a charged body. Means when the balloon is rubbed with paper, suppose if it is paper, so after some time from the paper it gains some charge. it will get some charge and it will become a charged body. It will become a charged body. So before that before rubbing it is a neutral body. Before rubbing it is a neutral body. So after rubbing for some time with not these papers, with another paper or with wall, with hair, like that. So from the object with which it is rubbed, from that it will gain some charge, minus charge or positive charge, depends on the object. So it will gain some charge and it will become a charged body. Now this charged body, if you brought near the papers, this is a charged body. It will have the power of attracting the pieces of paper. Attracting the pieces of paper. So the when you bring, so now suppose like this, if it is having minus charge, this is having minus charge particles. When it brought near the papers, it will develop a positive charge. It will develop a positive charge on the pieces of paper. So negative charge, positive charge, opposite charges will attract. So the balloon will actually balloon is getting negative charge because of rubbing. So if you brought near the paper pieces, it will make the paper pieces to get positive charge. So negative charge, positive charge, both will attract. So means when it is brought near the bits of paper, the pieces acquire opposite charge. Means if the balloon is having negative charge, paper pieces will get positive charge and cling to the balloon and get attracted to the balloon. So this kind of force exerted by a charged body like balloon on another charged body or uncharged body is known as electrostatic force. So this force also comes into play when the bodies are not in contact. Means at a distance, balloon is here, papers are here. They are not touching with each other, but still balloon is trying to attract the pieces of paper. Means this is an example of force at a distance or electrostatic force because of the charges. So magnetic force because of the south pole, north pole. Electrostatic force because of the positive charge, negative charge. Like this. If you rub the balloon, here suppose balloon has got positive charge. If you rub the balloon, if you bring it near your hair, from the hair, negative charge will be attracted towards the balloon. So that's why hair appears that it is clinging to the balloon. It is getting attracted towards the balloon. So this is an example of electrostatic force. This is the second type of force at a distance. Next, we have gravitational force. So this is third force, gravitational force. So it is our common experience that if the pen slips off from our hands, it falls down the floor. Suppose we are holding a pen. Suppose if it slips off, it will fall down onto the earth. The pen will fall down onto the earth. So why it is falling down means, what is the force which pulls the pen down means? So it is gravitational force, because the earth will be having gravitational force which try to pull all the objects down. So if we keep the same pen on the table, it does not fall down. Why means, when it is kept on the table, when the pen is kept on the table, already we have discussed it will be acted by the gravitational force downward, but normal force by the table upward. Both are equal. So that's why pen will not fall down. Pen will not fall down. So in that condition also, we have gravitational force, but normal force is balancing the gravitational force. So here, so the table supports the pen. If the table is not supporting the pen, it will fall down until it is supported by the another object. Suppose from the table, it falls onto the floor. From the floor, it is not going into the earth. Why? Means floor is stopping the pen. Because earth means earth will be like this circle. Earth will be like this circle. Earth will be having so many layers. The pen, suppose if it is here, the pen on the surface of the earth, it is not going to the middle of the earth. Why? Means the floor is stopping the pen. Floor is stopping the pen. Or when a stone is thrown up into the sky, it will fall down. Stone or ball. Or you might have observed rivers going and falling down into the sea. This is the sea part. This is the river part. Actually, this is the place in Kerala where the river meets the sea. Okay, rivers falling down into the sea. Or earth above, we have so many layers of atmosphere. Suppose this is the earth. 1 minute, children. Suppose this is the earth. Earth above, we have troposphere, tropopause, stratosphere, ozone layer, mesosphere, ionosphere. Like that, we have so many layers of atmosphere on the earth. So here, the stone is falling down. River is falling down into the sea. Atmosphere is there on the above the surface of the earth. Above the surface of the earth. So all these natural phenomena are earth is able to hold the atmosphere. Earth is able to hold the atmosphere. So all these natural phenomena, behind all these natural phenomena, there is some force. There is some force which is pulling the objects towards the earth. If the earth does not pull the atmosphere towards it, so this total atmosphere will escape from the earth. There will be no atmosphere on the earth. No atmosphere on the earth. So it is holding the atmosphere means there is some force pulling the atmosphere towards its side. Or there is some force in the sea which is pulling the river water. Or there is some force on the earth which is pulling the stone. So this force is called as gravitational force. This force is called as gravitational force. Gravitational force. So we call this force as the gravitational force. So every object on the earth or apple from tree or close to the earth will experience a gravitational pull. Gravitational pull. So here the force of gravity means it is not just due to the attraction of earth, not only earth, between any two objects on the earth or between any two masses like students. Suppose students in classroom, between one student and another student, there will be the gravitational force. Or between student and teacher, there will be the gravitational force. Or between the bench sitting by us, between the bench and the student, gravitational force will be there. Means on the earth, between any two objects, any two masses, or everywhere in the universe, between any two bodies, this gravitational force will be there. This gravitational force will be there. But why we observe only the gravitational force of earth but not the other forces means the earth is so massive and huge. So that's why all the objects close to the earth are attracted and pulled towards it. Means the earth is very, 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 very big. So that's why when you throw a stone into the up, you can observe falling of the stone. But when you sit in your classroom, there will be a gravitational force among you or among the other students, or between the blackboard and you. There is attraction force, but blackboard will not come to you, or you will not go to the blackboard. Means there is a attraction force. There is attraction force. Because of that, they are not getting attracted. Means the attraction force is very, 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 very small. We cannot tell attraction force not there. We have to tell between the blackboard and you, attraction force is there, but the attraction force compared to the earth is very negligible, very, 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 very small. That's why you cannot observe. But we should not tell there is no gravitational force. Or between the scale and pencil, between the scale and pencil, there will be a gravitational force, but very, very weak. Or between the earth and other planet, or other earth and moon, there will be a strong gravitational force. Why? Means because of their huge masses. Their masses are huge, very big. So that's why we can observe their gravitational force. So these masses are very, very small. We cannot observe the gravitational force. So you cannot experience the gravitational force that exists between you and your teacher, or you and your blackboard, because it is very small compared to the gravitational force exerted by the earth on these objects. Earth on these objects. So this is about gravitational force, children. So what we have learned, children, today? So what we have learned? So we have learnt about contact forces. Normal force means shown by the surface of contact in perpendicular direction opposite to weight. Opposite to weight means weight acts downwards, means normal force acts upwards. Both are equal in magnitude but opposite in direction. So that's why net force will be 0. As net force is 0, you can tell that they are in equilibrium. They are in equilibrium. So next, tension force means the force developed in the string. The force developed in the string. The force developed in the string. Because weight acts downwards, to balance that, the string will develop one kind of force called tension. One kind of force called tension. Both of them are equal, same in value, but opposite in direction. How much weight is there, that much tension will be developed in the string. Next, forces acting at a distance. Magnetic force. Magnetic force means force between the poles. Force between the poles. Without contact, this magnetic force will attract. Like poles, repulsion force. Unlike poles, attraction force. Or electrostatic force, because of the charges. So because of the charges, balloon tries to attract the pieces of paper. Pieces of paper means from the balloon, on the balloon one kind of charge will be developed. When it comes into contact to other body, opposite charge will get attracted towards the balloon. This is called electrostatic force, because of the charges. Next, gravitational force means because between any two masses, attraction force will work. So here magnetic force means attractive, repulsive. Attraction, repulsion, both we can observe. Electrostatic force also attractive, repulsive, both we can observe. But gravitational force between two masses always attractive. Always attractive. So, but here attractive force will be very weak between small masses, stronger between the huge masses. So that's why weak gravitational force we cannot observe. Strong gravitational force we can observe. So that's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.